One more question on KCL. Okay. Okay. In this circuit, we are only using independent sources only, not a dependent sources. Independent sources. So here the question is, we have to identify the value of V1. Okay. Where the V1 is, here it is a V1. What is V1 here according to the circuit? V1 is nothing but voltage drop across 3 kilo ohm resistor. In order to identify voltage drop across 3 kilo ohm resistance, we can use KVL and or KCL. Both we can apply for this circuit. But particularly in this case, I am using KCL, nodal analysis. Okay, here I am using nodal analysis only. By using nodal analysis or KCL, I am going to identify what is voltage drop across a 3 kilo ohm resistance. First of all, how can you identify voltage drop across the 3 kilo ohm resistance according to this circuit? So to get voltage drop across 3 kilo ohm resistance, that 3 kilo ohm resistor value 3000 kilo is nothing but 10 power 3 must be multiplied with current flowing through that 3 kilo ohm resistance. For example, I am assuming IA amount of current is passing through 3 kilo ohm resistance. Then we have to multiply that 3000 kilo ohm resistor with IA. Then we will get voltage drop across 3 kilo ohm resistance V1. So before going to identify V1, first of all we have to identify what is IA. Nothing but current flowing through 3 kilo ohm resistance. To identify the current flowing through 3 kilo ohm resistance, here I am using KCL or nodal analysis. Okay, try to understand how to apply KCL or nodal analysis for a given any type of circuits. Okay, to apply KCL or nodal analysis, just we have to follow three steps or the four steps. First step is identify identify number of junctions, and second step is indicate junction indicate a junction voltages. Third step is assume, so this is very important, assume a reference voltage as 0. Okay, and fourth one is apply KCL at each junction except reference junction. Okay, so these are the four steps we have to follow while we are applying KCL or nodal analysis. Okay, so before going to apply KCL, just keep one point. There is no KCL. In KCL, we are using KVL only. In KCL, we are using KVL only. Okay. How to identify how we are using KVL in KCL? Just try to understand. Okay. So first, we have to apply point number one. Identify a number of junctions. We have to identify a number of junctions in a given circuit. First, you should understand Wait, wait. What is junction. Then we can easily identify what is junction, what is the node, what is the difference between these two. Node is nothing but node. Node is nothing but it is a point, connecting point where two elements are connected together. Two elements are connected together. Or we can also say this as it is a point or connecting point where current won't will not divide. Means the current passing through first element and current passing through second element both is same. Current passing through first element and current passing through second element is same. That point is called as node. Okay, here at a node current won't divide. And the junction is nothing but junction is nothing but it is a point or node, a connecting point where more than two elements are connected together. Where more than two elements are connected together. Otherwise, we can also call it as say it as it is a point where current can divide. Where current can divide. At junction, current can divide into number of paths, but at a node, current won't divide. The current passing through each element is same. Okay. Okay. These are the 2 points. Okay. So after knowing that the difference between node and junction, but here all junctions are nodes only. All junctions are nodes, but all nodes are not junctions, not vice versa. You have to keep it in mind. All junctions are nodes, but all nodes are not junctions. Junctions. Okay. Now we have to identify number of junctions and nodes in the given circuit. Okay. Try to understand how to identify number of junctions and number of nodes in any type of circuit. So here, sorry. Mm. So before going to apply KCL, first of all, once again I am recalling it as there are two types of circuits. One is practical circuit, and second one is imaginary circuit. Imaginary circuit. There are two types. Both are same only, but the practical while we are doing experiment, the circuit connections are called as practical circuits. While we are writing on paper, while we are drawing circuits on paper, that circuits are called as imaginary circuits. Okay, so here it is imaginary circuit since because all the lines are drawn as straight lines. These are all straight lines only. All are straight lines. These are all straight lines. Even though these are wire connecting wires, they are drawn straight. But wires are cannot be a straight line. In our imagination, these wires are drawn as straight lines. Okay, but in practical way, while this imaginary circuit converted into practical circuit. Okay, let me draw that practical circuit for this given circuit. There is 3 kilo ohm resistance like this, 3 kilo ohm resistance. Okay, every element has two terminals. Okay, one positive terminal and negative terminal. Okay, this 3 kilo ohm resistance is connected to second terminal of 3 kilo ohm resistance is connected to 6 kilo ohm resistance like this. These two are connected in series. Then the first terminal of 3 kilo ohm resistance, the first terminal of 3 kilo ohm resistance is connected to here. The first terminal of 3 kilo ohm resistance is connected to one current source. That is nothing but 25 milliamps. Okay, this is like this, and the current direction is upward direction like this. 25 milliamps. 25 milliamps. Again, that same point where those two 3 kilo ohms and 25 milliamps are connected together, that point is connected to again 6 kilo ohm resistance. Okay, so this point, the same point, from this same point, there is one more 6 kilo ohm resistance connected like this. Okay, then the same point, these 3 points are same only. Okay, same point is connected to one more current source, that is nothing but 15 milliamps. That is nothing but 15 milliamps. Same point is connected to one more current source, that is nothing but 15 milliamps. This is the current direction, 15 milliamps. Okay. So according to this imaginary circuit and a practical circuit, the upper portion is same. These four elements are connected together like this in practical connection. Okay. Similarly, in down portion, the second terminal of 6 kilo ohm, second terminal of 25 kilo ohm, 25 milliamps, sorry, and second terminal of 6 kilo ohm, and second terminal of 15 milliamps, all are connected together like this, at a point. These two circuits are similar. Both are not. Uh, don't think those two circuits are different. Both circuits are the same only. So this is imaginary circuit. This is imaginary circuit, and this is a practical circuits where the connecting wires are carved into number of shapes. Okay. So just keep it in mind. The number of junctions in practical circuit should be equal to number of junctions in imaginary circuit. The number of nodes in practical circuit should be equal to number of nodes in imaginary circuit. Okay, so try to understand the practical circuit. In this circuit, there are two junctions. Okay, there are two junctions like this. So here it is a one junction because as per our statement, junction is nothing but where more than two elements are connected together. Okay, at this point there are four paths: one element, second element, third element, and fourth element. There are four elements are connected together at this point. We can call it as a junction because it is a junction one. I am noting it as J1. And again, at the bottom, there is one more junction like this. Here it is. At this point, there are again four elements are connected like this. So this is junction, more than two elements are connected. At this point, the current will divide into four paths. That's why it is called as junction. Here it is also. And according to a statement of node, there is one node. Here it is. Here it is a node. Because here 3 kilo ohms and 4 kilo ohms are connected together. The current passing through 3 kilo ohm resistance is exactly equal to current passing through 6 kilo ohms. So, because since these two are connected in series, same amount of current passing through these two elements. That's why the current won't divide at this point. That's why it is called as node. Okay. According to the practical circuit, there are two junctions and one node. Two junctions and one node. So similar to that, the imaginary circuit have have two junctions and one node. So here, okay, okay, this point is same as this point, and this one, and this one. These four points are same. So if you observe practical circuit, okay, then we call it as this is a junction one, and at the bottom, this point, second point, and third point, and fourth point. 4 points. Potential at these 4 points is same. That's why we call it as a junction. Junction. So here we have two junctions. Okay, junction one and junction two. And the node is a single node is like here it is. So this is the node. But uh, keep it in mind. KCL can be applied at a junction only, where current can divide into number of paths. We cannot apply KCL, no problem. But the current flowing at the node is the same. That's why we need not to apply KCL at a node. Okay. The first step uh, in this case is completed. Identifying number of junctions. In this circuit, we have only two junctions. In some cases, we can also have three junctions, four junctions, five junctions. According to the complexity level of question, we can get four or five junctions also. Okay, first point completed. Second point, indicate a junction voltages. How many number of junctions that you have identified? That much number of voltages we have to indicate at each junction. So, for example, at a junction one, uh, at a junction one in practical circuit, there is one potential. Let it be V1. Because don't confuse with the question V1. We can also assume VA, VB, VC, VX, VY, VZ, your wish. Uh, to indicate different notations, I am assuming here Vx. Vx is nothing but potential or voltage at junction 1. And also Vy. Vy is nothing but potential at junction 2. Potential at junction 2. These are since the given circuit has only two junctions, I am not indicating uh, two junction voltages as Vx and Vy respectively, J1 and J2. Okay. Now, the second step is also completed. And third step, assume reference voltage as zero. Assume reference voltage as zero. To understand this point, first we have to understand what is the reference voltage. Okay, in any electrical circuits, Among number of junctions, one of the junction is assumed as a reference. Every electrical circuit must and should have one reference junction only. Okay. In this circuit, we have only two junctions. Between these two junctions, one junction should be a reference and another junction is principal junction, main junction only. Okay. First, why should we have to assume reference voltage as zero? Okay. Uh, to understand the meaning of zero, uh, just question yourself when current will flow from one point to another point. When current will flow. When will current will flow? When will current flow from one point to another point? When it will flow? Whenever there is a potential difference between 2 points. Whenever there is a potential difference between potential difference between 2 points. Whenever there is a potential difference between 2 points, then there will be a current flowing from one point to another point. Nothing but high potential to low potential. Okay. In our while we are discussing about electrical potential and electrical potential difference, uh, uh, I explained one story that uh, in our street there is three line wire. On this three line wire, there is a bird sitting on that. There is a bird on sitting on that line. Since the line is powered with electrical energy, the bird won't get a shock. Why? Because, for example, we are getting a single phase voltage. At this point, we are getting 230 volts. At this point, 230 only. At this point, 230. At the point where the first leg of bird is also 230 and the second leg 230. The potential difference between these two legs is zero. That's why there is no current flowing from the body of the bird. So this is the path actually. But since there is no potential difference between these 2 points, there is no current passing through the body of the bird. That's why the bird won't get shocked. Okay, similar to that, if you want to pass a current from one point to another point, there should be a potential. There should be a potential difference. Then only current will flow from higher potential to lower potential. Okay. Okay. So in order to flow from here in this circuit, we have two junctions. Okay. So this is V1 potential and this is V2 potential. So between these two potentials, one potential voltage should be zero. The junction voltage where we are going to assume the voltage of that junction equal to zero, the junction is called as a reference junction. Okay, so between these two, I am assuming the V2 voltage equal to zero, and V1 should be greater than zero because in order to flow current from junction 1 to junction 2, there should be a potential difference. Yes or no? Okay. Uh, since I am assuming the value of potential at junction 2 is 0, as the voltage as 0 for reference, then the value of V2 should be greater than 0. not equals to 0. If it is 0, these two junctions potentials are equal and potential difference is 0. Then there is no current flowing from one junction to another junction. Because of potential difference between V1 and V2, there is a current flowing from V1 to 3 kilo ohm, 6 kilo ohm, and V2 equals to 0. Since there is a potential difference between V1 and V2, the current flowing like this. Since there is a potential difference, there is a current flowing through 6 kilo ohm resistance. Since there is a potential difference, okay, uh, for that we are assuming one of the junction voltage as a reference. Commonly, we always use the down junction as a reference voltage in any electrical circuits. Uh, it is not the uh, compulsorily we have to assume a down junction only. We can also assume upper junction also. No, don't worry. Okay. So according to that point number 3, assume reference voltage as 0. So in this circuit, the V2 voltage is 0 because I am assuming junction 2 as reference. Junction 2 as reference. Okay, this is the potential. Now we have to apply KCL at each junction. And that is the fourth step. Okay, let me explain. Now we have to apply KCL at each junction. So as per the point number 1, 2, 3, this is a junction 1. And this is junction number 2. The potential at junction 1 is V1. Potential at junction V2 is equals to 0. V2. And according to the statement 3, V2 reference voltage as 0. Now we have to apply KCL at each junction. So according to the KCL, sum of incoming currents is equals to sum of outgoing currents. First, we have to identify, indicate current directions at each junction. Indicate current. So since it is a junction, so at this junction there are four paths: first path, second path, third path, and fourth path. Four elements are connected together. So that's why there are four paths. And the current flowing through each path is we can assume any direction, either into the junction or out of the junction. You can some of the junctions are into the junction, some of the junctions out of the junction. You can assume any direction. Here I am assuming all are outgoing only. So this is outgoing current from the junction 1, and this is also outgoing. This is also assume outgoing, and this is also outgoing. All are outgoing currents only. No need to consider all are outgoing currents. You can also assume any one of the current paths as incoming and some remaining as outgoing, or all are incoming also. So okay, this is a current one I1, and this is current I2, and this is current I3, and this is current I4. Now apply KCL at junction at each junction except reference. Uh, okay, except reference, we have to apply KCL at each main junctions or principal junctions. So according to KCL, sum of incoming currents is equals to sum of outgoing currents. So if you observe the current directions in this junction, in the circuit, all four currents are coming out of the junction. It means all are outgoing only. There is no incoming. So since there is no incoming currents, 0 equal to sum of outgoing currents. All are outgoing currents only. That's why I1 plus I2 plus I3 plus I. Okay. Okay. Simply we can write it as I1 plus I3 plus I4 is equals to 0. Let it be equation number 1. So this is the equation number 1. Now we have to write equation for I1, I2, I3, I4 in terms of junction voltages. You have to write equation for I1, I2, I3, I4 in terms of junction voltages. Okay, try to understand how to get equations for I1, I2, I3 and I4. What is I1 here? Here I1 is nothing but current. Here I1 is nothing but current flowing through 3 kilo ohm resistance, 6 kilo ohm resistance. Here the current starts from V1 and end at V2. So this is the current direction of I1. It starts from V1 and end at V2, passing through 3 kilo ohm resistance and 6 kilo ohm resistance. Just redraw that path where I1 starts and end. So here the current starts at V1 and passing through 3 kilo ohm resistance, 6 kilo ohm resistance and end at V2. Here the value of V2 is 0. Okay. Here it is 3 kilo ohm resistance and this is 6 kilo ohm resistance. It is a starting point V1. This is a starting point and this is end. Okay. In this case, the value of starting voltage as negative, I am assuming here, and the value of end voltage as positive. Okay. Okay. Now apply KVL for this loop. For this. Okay. If you apply, and the current direction is like this. I1. Apply KVL. Okay. At starting point, the voltage is V1. Since it is V1 and the starting point is assumed as negative, it is nothing but minus V1 plus 3 kilo ohm resistance, nothing but 3000 I1 plus 6000 I1 plus and end voltage is nothing but V2, that is equals to 0. Here the V2 value, reference voltage value is 0. After simplifying this equation, then I1 is equals to V1 by 9000. So this is the expression for I1 in terms of V1. Let it be equation number 2. Here we got expression for I1 in terms of V1. Clear? Similarly, we have to write equation for I2, I3 and I4. Okay. Now I2. Here I2 starts from V1 only and end at V2 through a current source 25 milliamps. Okay. Just to read that circuit. Let me draw. This is for I2. It starts from V1 passing through a current source 25 milliamps and end at V2. The value of V2 is 0. Since it is a reference voltage, the value for reference voltage is 0. And the current direction in this path is like this. And it is nothing but I2. Okay. I2 means current passing between those 2 points V1 and V2, where the potential difference between 2 points is V1 minus V2. Okay, here current passing through between these two, but the element is itself a current source between these 2 points. Current, the current uh, between these 2 points, the element is current current source itself, 25 milliamps. It means between these 2 points, 25 milliamps of current passing from V1 to V2 or V2 to V1, whatever it may be. This must be equal to I2. But this 25 milliamps is the actual current flowing between V2 to V1. But my assumed direction is I2, which is flowing from V1 to V2. This is the direction of my assumed direction. 25 milliamps current is like this. That's why I2 is nothing but minus 25 milliamps. That nothing but minus 25 into milli means 10 power minus 3 amps. So directly we got I2 equation, not in terms of V1 and V2. Here we got the value of I2 directly. But in case of first case, we got expression for I1. We won't get the value directly, the value of I1. Here we got the value of I2 directly. Okay, similarly, I3. What is expression for I3? First, observe what is the path for I3, where it start and where it ends. Okay, here I3 is starting from V1 and end to V2 through 6 kilo ohm resistance. Just redraw that path carefully as it is 6 kilo ohm and at V2. This is V1 and this is 6 kilo ohm resistance. And the current direction is like this. I3. Okay, this is the starting point and this is the ending point according to my current direction. If the current direction is bottom to top, V2 is the starting point, V1 is the ending point. Okay, now apply KVL for this loop. Minus V1 plus 6000 I3 plus V2 is equals to 0. Here V2 is equals to 0, then I3 is equals to V1 by 6000. That will be equation number. This is 2 and this is 3. And equation number, sorry, this is 3 and this is 4. And equation for I4. What is I4 here? Current passing from V1 to V2 through 15 milliamps. Okay, draw that path from V1 to V2 through a current source 15 milliamps. Here V1 is equals to 0 and this is 15 milliamps. And my assumed current direction is like this, I4. So, okay, since it is a current source, the current passing from V1 to V2 is nothing but 15 milliohms. That is equals to I4. And the assumed current direction and actual current direction both are same direction. Then I4 is nothing but 15 milliamps, nothing but 15 into 10 to the power of minus 3. Let it be equation number 5. Now substitute these second equation, third, fourth, and fifth equations in equation 1. What is equation 1? Equation 1 is nothing but I1 plus I2 plus I3 plus I4 is equals to 0. What is V1? We got V1 by 9,000 plus I2 is nothing but minus 25 10 power minus 3 plus what is I3? V1 by 6,000 plus I4. I4 is nothing but 15 into 10 to the power of. Okay. After simplifying this equation, V1 by 9 minus, sorry, this is minus 25 plus V1 by 6 plus 15 is equals to 0. Okay. V1 is 1 by 9 plus 1 by 6 is equals to 10. Plus 10. After simplifying this expression, then V1 will be very inverse. It's V1 is equals to 36. Sorry, VA. Here the junction one is nothing but VA, junction two is nothing but VB. Okay, sorry, don't get confused. This is VA and this is also VA. This is VA or VX. Your wish. Whatever it may be. VX, VX. All are VX only. So finally, I got the value of Vx. What is Vx here? According to this value, the voltage at junction 1. Vx is nothing but 36 volts. And what is Vy? Vy is nothing but 0 volts, reference voltage. Okay. So there is a potential difference between these two. That's why current flowing from high potential to lower potential. But our question is, we have to identify V1. What is V1? Potential drop across 3 kilo ohm resistance. Then potential drop across 3 kilo ohm resistance is V1 is equals to 3000 into how much current passing through that 3000 kilo ohms. I1 according to my notations. So there is a I1 amount of current passing through that. Okay, then V1 is equals to 3000 into what is I1 expression? Vx by 9000. Here, here it is Vx by 9000. Okay, here three zeros, three ones are three threes are Vx by 9. What is Vx? After solving KCL equation, we got Vx equals to 36 by 9. Then, then 36 by 9 is equals to 4 volts. 36 by 4. Okay. Any missing? So finally we should get 12 volts. Here the answer should be 12 volts. Is there any mistake? Vx by 900, Vx by 900, 625. Is it 25? And 15 milliamps. Okay. Then 0 point. Vx is nothing but 36. V1 is nothing but 3000 into I1. I1 is nothing but Vx by 9000. 3000. Correct. Here it is not 9. Sorry. Vx by 3. Sorry. Vx by 3. So 36 by 3. What is 36 by 3 value? 12 volts. So this is the final answer. Okay. I hope you understand how to apply the KCL. Thank you.